All right. So first thing is knowing when it is. It's going to be during our normal test time for, not test time, our normal class time next Tuesday. This guy here. Next Tuesday. In terms of how to find it, let me go ahead and share this with you guys. All right. Sorry about the second screen. I know it's going to come up a little bit tiny, especially for some of you. If you go to your normal Canvas page for our course, go to either, if you're on a cell phone, modules, or if you see this one here with all the brightly colored buttons, go to the top thing that says daily information. And what you're going to see here at the very, very top is something that says test 3. You should be able to see it right now when you go to Canvas. And what will happen is, just like with test 2, I'm going to go ahead and have a button that you can go ahead and where is it? Click on to get to the test directly. Study guide for test 3 you can find right now, and the practice test 3, again, I'll put the link right there once you find it. I mean, once it's done. So let's get out of there now. All right. So in terms of the topics that this is going to cover, it's going to cover the stuff that we've done since test 2. So that's broad strokes induction, dealing with sequences, and then dealing with posets. So it's only going to be 3 broad strokes topics. In terms of induction, here's what you should expect to see. You should expect to see roughly 2 questions. In terms of formatting, I'll make sure to put one of these guys on the practice test 3 so you can see the formatting. But if you want to start looking at it right now, that Canvas quiz, the one that was called Activity Induction, that most of you did, will be, what was it? I believe it was the last question, so question 3 would be a sort of sample type thing that you could have with respect to what you could see with how an induction question might work when you're looking at something online. Okay? Now, in terms of other questions, could you also be asked other semi-multiple choice questions like you were in that same activity? Yeah, sure, but realistically, we're probably going to focus on actually working through an induction question. Okay? In terms of types of questions that you could see, one of them, I'm going to try to make a really straightforward, really basic type case. So this would be something exactly like what we did. Both of them would be similar to what we did in class. So basic question. This one here, it might be a sequence question like some of the ones we did in class. It might be a factoring question like the one that's currently on this activity right there. And then the second one would be something a little bit less basic. So maybe it would include something like an inequality, just because those have a tendency, it's the same idea. The inequality just sometimes makes it feel a little harder. It might be something where it's type 2 or strong induction. So this would be, maybe it's a sequence question, because for us, all of our examples with strong induction have dealt with sequences. Or maybe it's just another one that's not the same format as the first guy. Okay? So realistically, you should expect 2 induction questions. Okay? And that's if they're both full out doing the full proof like what your homework is. So here, in terms of things to look at the homework associated with induction. I believe that was homework 11, if I remember correctly. Okay. Now, what happens? Maybe you have only 1 induction question. If that's the case, you would have a second, maybe a third question that asks you about pieces and parts of some other induction type thing. So maybe it would be something similar to this quiz that said, hey, or this activity that says, hey, should you use the strong or the weak induction? Or maybe it's something that says, what's the basis step? And then all it asks is, what's the basis step? Okay. So it might be there's 1 full induction question and 1 partial-esque induction question. Haven't fully figured out the second one, but for sure there's going to be 1 full one. All right, so that's induction. should definitely look at those 3 guys. Now, in terms of sequences, we did a couple of different things with sequences, and here's what you should expect to see. You should expect to see something that is a second order sequence where you actually have to grab your characteristic equation of the given recurrence relation. So this is where you're given something like some number times the previous term plus some other number times the term before then. And then you have where the first 2 terms equal something. And then where are you trying to find? You're trying to find the closed formula or the formula that looks like a function where that nth term equals something something only in terms of n's, not the previous terms. Okay? So this is where you'd have to worry about the roots of your characteristic equation, and then you have to put it in the correct form. Okay? So that is, you're pretty much guaranteed to have one of those questions. Now, since we talked about the formula for first order as well, you're probably also going to have a question that deals with first order sequences. They're much simpler. You can do them in several different ways. We talked about arithmetic, geometric, and then the general format. So this is what we talked about. We talked about arithmetic. This is previous term plus something. We talked about geometric, which is previous term times something. And then we did the general form. I don't remember what letters your author uses. I want to say S, previous term plus T. I don't remember where he put the S and the T. They might be switched. Okay? So those would be the 3 formats that we talked about, and we actually gave a formula of what you would do to find that closed form for all 3. So it's highly likely that you get one of these guys. It's highly likely that you get one of these guys. You may also be something that is simple as you're given the formula. So maybe you're given, hey, this guy is 2 times the previous term plus 1, and you're asked, hey, what's the first 4 terms? I'm going to stop writing now. Don't overthink it. Literally just plug in the numbers and figure it out from the formula. Maybe you're given something where it's the actual closed form. Maybe it's something like, oh, I don't know, maybe n squared over n minus 1. In this case, it's even easier. If you're trying to find the first couple terms, just plug in the value of n and figure out what those new numbers are. Okay? So you might have something easy like that. So there's 3 possibilities of different things that you could have. And remember, in terms of our second order guys, your roots could be either, I noticed this here, we didn't talk about it before, could be either repeated or distinct or non-repeated, if you will. Okay. So that would be, roughly speaking, what you could see with your sequences. Okay. And then the last thing deals with posets. So far in class, so before today, we've talked about everything above that blue line right there that I put in. So this one here, maybe you have a question that says, verify if this guy is a poset. Okay? So if somebody is a poset, what do you have to have? You have some set A, you have some guy R, where R has to be something called a partial order. And remember, partial order meant you were reflexive, you were anti-symmetric, and you were transitive. So if you had a question like this, maybe it would actually be a free response question, and you'd say something like, yes, it is a poset because R is a partial order, and then you'd say why R is a partial order because it's reflexive, symmetric, transitive. Or maybe you have some question like this, and it's very similar to test 2 when you were asked, here's some relation, what properties does it have? Is it reflexive, irreflexive, symmetric, asymmetric, anti-symmetric, transitive, etc. Maybe it's something that looks very similar to test 2. Okay? So I haven't figured out if I want to do that question, and if I want to do that question, how to word it. But those would be the 2 general formats. Now, the next one is make sure you know how to grab a Hospitai diagram or make a Hospitai diagram from a given poset. For this one, you could see several different things that you could happen. It could be that this is something like a multiple choice question, and you're given the post set, and then you're given a bunch of different pictures of Hosta diagrams, and you have to select which one it is. So it could be something like that. It could also, and this is something I am considering doing, is having you have one question that you actually have to upload. It would have to be a separate assignment than test 3. So it'd be something like test 3, all the main questions, and then test 3, the one extra question. And so inside the test, it would say something like, make the Hosta diagram of blank post set. You're going to have to upload this file after you get it out of the test. And then maybe it asks you some questions about that post set. And then when you finish the test, you go to that second place and you upload your picture in that second assignment. It seems very complicated, so I haven't decided if I'm going to do it that way or multiple choice. You definitely would get partial credit more if we do it that second way, though. So I'll figure that out, and I'll let you know for sure on Thursday if you'll have that upload file or not. And if we do have that upload file, I'll try to figure out a decent way with the practice test to show you how those things go. Although realistically, I can't think of how to do that for the practice test easily. So anyway, so that is dealing with making a Hosta diagram. In terms of isomorphic, remember for us, for post sets, isomorphic just meant you had two post sets and their Hosta diagrams looked identical. So if you have some sort of question about this, you would probably be given one of the post sets and its Hosta diagram, and then maybe you're asked to create the Hosta diagram of the second post set. So maybe that links with this guy right here. And then you're asked a follow-up question, something along the lines of, hey, are these two post sets isomorphic to each other, yes or no? Okay. So that would be the idea here. Or maybe it would be a matching question, and you have a bunch of Hosta diagrams of various post sets, and you're asked, hey, which one of these guys are isomorphic to each other? Don't overthink it. Find the ones with the same picture. Which is why you probably won't have that last one. Now, these are the things that we still have to cover later today and then on Thursday. We're going to talk about today maximal, minimal elements, greatest or least elements, and then their symbols. Depending on time, we'll get to what lattices are. This one here will probably be today and next time. And then we're going to talk about Boolean algebras. It turns out there's really only one fact that we're probably going to get to in this course, and that's telling you what a Boolean algebra is and then when Boolean algebras are isomorphic to something else. So I can literally do that in less than 10 minutes. So in terms of things that you would see, this would be something where maybe you're given the post set and you're asked, is this a lattice? What are the meets and joins, which once you know what they are, inside of your lattice? And for a Boolean algebra, you might be something like, is this guy a Boolean algebra? You'd use your definition to check. And then you might say, is it isomorphic to any of these other guys? Maybe something like a multiple choice question in that case. Okay. So that would be the overarching things. Notice here, structurally, you'll need to know definitions and then how to find those pieces and parts inside of your post set, specifically inside of your Hosta diagram. Up here, you're recovering or building your formulas. And for the induction, this one is, realistically, you're going to see fill in the blank proofs, okay? Where you'll have to worry about filling in certain pieces of the proof. Okay? But that's the overarching guideline in terms of things to look for. Examples we've done in class, homework examples. We've had not very many activities since we've gone online, but we did have that one on induction that was in Canvas. So, questions from you guys? But that's the basics in terms of what I'm expecting to put together. All right, I'm not seeing any questions come through, so let us jump into dealing with post sets some more. All right, so let me first share this other one just so we don't have a glitch on my end. All right. So just to give ourselves a little bit of a running start, we've actually already talked about this stuff a little bit. In terms of a post set, it is right down here, this second written out definition. I just totally copied what we had from last time. Our post set stands for partially ordered set. It consists of both a set as well as a relation, where that relation has to be a partial order. And here's our definition of a partial order of the first definition that says, hey, it's some relation where you're reflexive, antisymmetric, and transitive. Okay? So as long as you have a partial order attached to a set, that's a post set. Now, one of the big things that we did last time is we looked at how to build the Hospitai diagram of post sets. So, lost my cursor. So let's go ahead and scroll down here. So the key thing with the Hospitai diagram was it looked just like the digraph of relation, except no, it didn't, because we removed all of the loops. Remember, the post set's reflexive, or the partial order's reflexive, so we went ahead and removed things we knew for sure were there. We also removed those transitive edges, and to remind ourselves, transitive edges look as follows. You have A's related to B, B's related to C. If the transitivity property holds, you have to then have A related to C. So that red directed edge, that's the transitive edge. Please note, transitive edge is not a real name. It's totally just a descriptor to try to remind you of what type of edge we're dealing with. Last step was when we converted from the digraph to the Hospitai diagram, we reoriented so all of the directed edges, all the arrows were pointing upwards, and then we removed the arrowheads so they're no longer arrows. Okay? And that right there was our crash course in Hospitai diagrams. We found the Hospitai diagram using this method once, and every other time we used tricks in dealing with building our Hospitai diagram, going up level by level. And the last thing we ended on last time was dealing with isomorphic post sets. And specifically, we had a whole technical paragraph, which I'm not bothering to write down again here. But the thing to take away at the end of the day here was you go ahead and have two post sets are isomorphic to each other. Technically speaking, they have the same structure. But what does that mean? That means when you build their Hospitai diagram, they have what looks like the exact same Hospitai diagram. Maybe one's the mirror image of the other because you flip-flopped where you put the vertices, but they are the same Hospitai diagram if you erased off all the labels. Okay? And that was where we ended last time. So this time we're going to talk about components of post sets, but before we get into that, I have a example/activity for you guys. This is why you guys were all automatically unmuted when you came in today. Okay? So here's the directions. I have automatically, as you guys were entering the session today, have WebEx throw you into groups. I have absolutely no idea if you guys will be able to see your group number or not. So I'll tell you who's in what group in just a second. Okay? So here's what's going to happen. I'm going to let you guys look at building your own Hospitai diagram. I would definitely recommend having something to write with, whether it's a piece of paper or on your electronic device. One person in the group needs to be able to write something down so everybody else can see it. It does not matter who that person is. You guys can pick, okay? Just make sure somebody from the group can do that. Now, in terms of what you want to do is you'll create this Hospitai diagram. Depending on which group you're in, your N will be something different. Okay, so everybody gets something a little bit different. Now, the second question is, once you've gone ahead and found your diagram, you want to see if you can't convert it into an electronic form. So hopefully somebody can do that in your group. And then you want to post it up onto our channel in Discord, and the direct link to that is on Canvas under today's page. Okay? Then you look at everybody else's picture once it's been posted, so hopefully everybody can post this. We'll see how this goes. And maybe your Hospitai diagram or your post set is isomorphic to one or more of somebody else's post set that they were working on. Maybe it's not isomorphic to anybody. Maybe it's isomorphic to exactly one. Maybe it's isomorphic to 2 or 3. Okay? So you look and see who it's isomorphic to. Do please actually label your picture with D with whatever your number is. That way the other people can actually see what's going on to answer the second question. Okay? So I'm going to go ahead and share who's in the different groups. And if you guys have any questions, go ahead and ask them or type them in while I'm going through your groups. So listen for your name. I'm just going to go down last names because everybody's got different last names in this class. Group number 1. So do write down what group number you're in because that determines what your N is for your post set. Group number 1 is Castro, Hager, Lozano. Group number 10. Yes, they alphabetize them in this way. And no, it's not alphabetizing, it's numerical. So weird. Britain, you didn't put your last name. I'm trying to remember it correctly. Panduri. And starts with an S. Sefid Diznab, the one I can never pronounce, sorry. Team number 2. Arrington, Johnson, Bandari, Washington. Team number 3. Majeski, Grimes, Vitarsi. Sorry. Team number 4, Brooks, Harmon. Team number 5, Minicello, Holman, Adder. Yes to that question. D with a subscript N is where you're dealing with all of the positive divisors or factors of N. Team number 6, Cooper, Cratch, Uhas. Team number 7, O'Hara, Anderson. Team number 8, Shang, Griffith, Rathor. Team number 9, and the last one is Hupka, Marez, Sarat, and Gapati. Okay? One of you is automatically tagged as the presenter, but all of you should be able to mute and unmute yourself automatically. So when you get into your group, feel free to unmute yourself as long as you have a mic so you can talk to everybody. Okay? So hopefully that'll work. Did everybody get what their ends were? Hupka, you are number 9. Oh, man. No. I believe you were, just a second. You were number 5, Keith. Griffith, just a second. Yes. Washington, just a second. Yes. Tyler, you're right. Adder. Oh, no, they're not alphabetical in any way, shape, or form. Just a second. Number 5. Zach, you're number 5. All right. So I think, I'm not 100% positive, but I think you'll actually see your number when you go into the breakout session. It should say breakout session number displayed somewhere. Don't know if that's true or not. I'm just crossing my fingers and hoping here. Now, you can find this directions right here. If you go to our Canvas page, I am going to share this with us right here. So this is under modules, daily information. Go under today's date, which is April 21st. And right here under the bold red text, this is that same activity. I typed it all up, including the chart, and this is the link to where you can display your pictures, mainly because I wasn't sure if they would display right in WebEx. Okay? So I'm going to throw you guys into the breakout sessions. You will not be able to see anything I'm currently sharing with you. So if you need to open up Canvas on a separate browser or wherever, definitely do it. Okay? Any questions before I throw you guys into these groups? All right, I'll periodically come in and cycle through checking on you guys, but you should be able to all mute and unmute yourself. That way there's none of the issues that we've had every so often with people not being able to talk to each other when we've done the groups before. So I'm about to throw you guys into your groups. 3, 2, 1, here we go. Never mind, I pushed the wrong button. Just a second. Okay, that's weird. It's not letting me start. Of course it's not letting me start it. Just a second. Technical difficulties. Let's try this.